Hello students, welcome back to OrganiChemVerse. In this series of videos, I am going to solve questions based on JEE Advanced level. Today, I am going to solve a question based on the aldol condensation. Let's analyze the reaction first. There is a reactant molecule given. It has two carbonyl functional groups and there are alpha hydrogens. Therefore, when it is treated with dilute NaOH heating condition, it is undergoing intramolecular aldol condensation. Why is it intramolecular? Because the reaction is taking place within the molecule. There are two possible products. One will take path 1, the other will take path 2. Now we need to choose which is the ideal path here, path 1 or path 2. When the product will be formed according to path 1 is when we choose the carbanion here. When the carbanion is formed here, it undergo enolization and further it will attack the carbonyl group. Right? Then it will form the product what is shown in path 1. How did we decide this? You can do a retro analysis here. That means what? You cleave this bond, you add 2 hydrogen here and 1 oxygen here and then observe. We have CH3CO, CH3CO and then rest will be CH2, and then CO. So that means what? It is nothing but as given in path 1. Same way, let's check for path 2. Which is the carbon attacking the carbonyl so that we'll end up with the path 2 product. It is this carbon, say 1, 2, 3, 4, 5, right? And we have a methyl also, right? At beta position, right? Or you can do the retro. So here you see CH3CO, CH3CO, then we have CH2CO, right? So this is the other way of solving it. So that means what? If the carbanion is formed here, then we are going to get the path 2 product. Now how to choose path 1 or path 2? It is something depend on the stability of the product formed. Thermodynamically, which product is stable? The product 2 formed by path 2 is more stable product. Why so? Because when we get alpha beta unsaturated carbonyl compound, what is the stability of the double bond? More the substituents, more will be the stability of the double bond. Because when we have more carbons, we tend to have more alpha hydrogens or also allylic hydrogen, which will stabilize the double bond due to hyperconjugation. Therefore, this product is more stable. Although the carbanion formed here is secondary carbanion, due to the stability of the product, we prefer path 2. In case of path 1, although we have a primary carbanion, it's kinetically stable. That means what? The formation of primary carbanion is quick, right? Therefore, it is going to form the product shown here. But what about the substituents? We have less number of substituents here. Therefore, this double bond is not so stable. Therefore, among the given 4 statements, path 2 is better than path 1 is a right option. And in path 2, more substituted double bond is formed in final product, which is more stable than the less substituted double bond product in path 1. This is also the correct statement. Therefore, the right statements for the given question is C and D. Thank you for watching this video.